I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have enough.
One of these days.
Had I been paying attention, I would have known immediately that this radio had been worked on, because the capacitor, there are supposed to be two power filter caps right here, mounted here, and they're gone, which means, of course, that somebody got into the radio and replaced them with these guys right here. But the rest of it looks pretty original, some kind of crude wiring there, but I don't know, maybe it's crude anyway. So what's next? I think I have a parts chassis for this, which will give me a couple of these square shields, which are kind of rare and odd. So I have to look through my stuff for that, because I need one there and I need one here as well. The later versions of this, the earlier versions rather, used to have a shield on this tube as well, but this one does not. But first things first. I've been, in preparation for cleaning the chassis, I've been pulling the tubes. And what I use is, I like clean tubes, but I don't want to erase the mark on the tube that says what type it is, because it's just barely on there, and I can't see if you can see that. Let's see, right there. It says type. It says 80, and don't touch that with anything. Don't touch it with water. Don't rub on it with anything. Go around it as best you can. I use a little window cleaner on a paper towel to clean the glass. But the Type 80 tube is, if you rotate it a bit, you can feel the glass is not attached to the base any longer. They used some kind of glue in the olden days. So what I'll do is I'll pull all the tubes. This one's loose. This Type 6A7 is loose as well. The one that's stuck in here is loose. So what I'll do is I'll put just a thin bead of super glue down around the edge. Other people use other kinds of glue. Super glue seems to me to work just fine. So that's what I'll do for that. I'll pull the other tubes and I'll show you I'm getting this, going to try to get this stuck one out of there. Okay, the remaining tube is the 6D6 in the corner here. And it's, since I can't grab the tube shield base, prevents me from grabbing it much. So what I'm going to try to do is the pins for this tube. Zoom in a little bit. Are right here, poking out of the bottom of the socket. I'm just going to push on those pins that are exposed with the back of this little screwdriver. See if I can just push that tube out a bit at a time. Try to do this without stabbing myself in the hand. Yeah, it's coming. Another tool might be my chopstick pointer. See if it's out enough that I can grab it. This one is very loose. The glass is very loose in the base. I really don't want to cause it anymore. Don't want to damage it if I can help it. Still pretty tight. Yeah, slowly coming out. Sorry, I zoomed you out so far. There it is. Came out. And it is a Super Airline Mark III. MK3 Super Airline 66, very loose at the base. You know, and I haven't tested these. I don't know if these tubes are good or not. I'm just going to clean them up and glue them for now. The assumption that they're okay, and I don't want them to get damaged any further. And I will then test them later. I'm just cleaning them up now and making sure I don't rub out the 66. Those, I think those are just screen prints with water-soluble ink. All right, looks better. Garbage. Then what I'll do, since I have it right here in my hand, is I'll just prop it up in that base right there. If I can get it to fit properly. There. Then I'll run a little glue around it. This is not the gel type super glue, by the way. We'll do this with the other tubes and then move on with the cleaning. Okay, I've got most of the surface dirt off everywhere. Got a piece of cardboard on the speaker so I don't inflict any damage on it. The next thing I want to get off of here before I do anything else is the dial. I don't want to damage the dial. And as far as I can tell, if you look right back here, there's a set screw. Zoom in a little bit here. There is a set screw right here. And I'm going to see if I can loosen that set screw. This mechanism should come off the tuning capacitor shaft when I do that. Okay, let's see if we can get that grub screw out of there. I think there's only one. Oh, it came pretty easily. Right, I won't unscrew it all the way, I shouldn't need to. I don't want to grab it by the plastic dial. I presume it's very fragile, but good, I can push it off. And then, there it is. It's in pretty decent shape, actually. For you Philco people who know Philcos, the part number on the dial is 27-5102. That might tell you which type this is. I'm pretty sure it's a type 5, but pretty sure and not absolutely sure. 2 dials. This one has standard labeled all the way across, 55 to 150 on the dial for AM. Also has a police band, 1.5 to, what is that, 4.0 megahertz for police band, or kilohertz. I'm not sure which. Police band hasn't been in use in the United States in quite a while. There's also a band here in the wavy lines marked aircraft, and then a little tiny slice of bandwidth here called amateur. So amateur, aircraft, police here, and police here again, and then nothing in between. But I'll put that in a special place. I'll clean up the aluminum, or the mounting disc first, then I'll put it in a special place and make sure it doesn't get damaged. The next thing I want to take off is this piece of plastic here. This is, the light shines through that slit and shows a slit on the dial, the dial face, so that you get a slice of illumination on there showing what station you're tuned to. But I want to get that off because it's also as fragile as the dial, and it's just held on by a 1/4-inch screw here. Which also might be mounting. Nope, it's not. So that's off. I'll put the screw back where it came from. And we'll dust this off and set it aside with the dial. Okay, we have the surface dirt off, have the delicate parts removed, speakers protected. Now it's time to check out the power transformer and a few other things before we apply any power. And let's go to the schematic so I can show you what I'm talking about when I say that you can probably cause more damage to this radio than age has already done for it by just plugging it in. There are some critical parts in old radios that need to be looked at before they're plugged in, thereby avoiding damage to the radio itself. And we'll take a look at that on the schematic. Here's the schematic for a Philco 60. There are a couple of things to know about schematics for Philcos. One is that most often what you'll get, in my experience, is the first iteration of a chassis. The Philco 60 was made from, or 60B, I should say, was made from about 1933 through 1935. And it had 3 or 4 or 5 iterations. In other words, they redesigned the chassis slightly. Bigger changes happened in the first year than in the second. And in the last change, there was only one circuit board difference. but you need to be aware of the differences between the 60s. And I'll point out a couple of things here that are important to know. One is right here in this section, you'll see a 8 microfarad capacitor, another 8 microfarad capacitor, 0.05 microfarad capacitor, and a 5,000 ohm resistor. This is in the first version of this circuit. In later versions, these guys right here all disappeared. These guys went away and never came back. So the version that I have sitting on my bench should be the latest version of the schematic, and those shouldn't exist in the circuit. We'll check that later. The last electrical change made to this circuit by Philco was right here on the 78 tube. This grid right here is called a suppression grid. It's this last grid before the plate. And in the 1934 version of this circuit, they ran this suppression plate straight to ground. So instead of going down through and connecting to the cathode, as this one does, and then over through a 200 ohm resistor to ground, it actually went straight to ground. So this is pin 4 of the 78 tube. And it should go, if the chassis I have on my bench is the latest version, pin 4 of the 78 tube should go straight to ground. And as I said, that was the last change. So if you have a 60B chassis and you're thinking it might be the last one, that's an easy check. Does pin 4 of the 78 tube go to ground? The 78 tube lives in this socket right here in the corner of the chassis. This is the 66 that I pulled out. These tubes are different than if you're only familiar with the newer 8-pin tubes. These are a little bit different in how you figure them out. There are a couple of things. One is it only has six pins. 2 of them, this pin and this pin, are larger than the other 4. So that's one thing to keep in mind. And secondly, the base of this tube has an arrow right here. I don't know if you can see it in the reflection or not, but there's an arrow right here. And what that means is if you're looking at the bottom of the tube or at the tube socket from underneath, pin 1 is here. And just like all the others, we go clockwise. So this is pin 1, pin 2, pin 3, pin 4, pin 5, and pin 6. So in this socket, we can turn that over, up on its side rather. Get some light in there. And I'll zoom you in so you can follow what I'm doing. Okay, 78 tube sockets right here. The 2 big pins, and they're noticeably bigger, are here and here. And then the other 4 are all the same size. Looking from the bottom again, this pin is our pin 1. So pin 1, pin 2, pin 3, and pin 4. So what we're looking for is if pin 4 is grounded to the chassis. That's our expectation. So I'll turn on the ohm meter. Zoom out again here. Turn on the ohm meter and we'll see what we see here. Black probe goes to ground. 1, 2, 3, 4. So this should be 0 ohms. And it is. 0 ohms. So pin 4 is grounded. That means that this is the last version of the chassis. This is the last electrical version they made. the latest, if you will, the latest in Philco 60 chassis is right here before us, the very one. One other thing I should mention, I guess, is when I was pulling tubes out of this thing, you may have noticed that I did not pull a 78 tube out of the chassis. I pulled a 6D6 tube out of the chassis. 66s and the 78s are identical electronically, and the pinouts are the same. Tube base in this case is the same. So it wouldn't be a surprise. It didn't surprise me to see the 66 in the 78 tube socket. That's a perfectly fine substitution. Won't cause any problem. So the tube's okay. So rather than a 78, my radio on my bench, rather than this 78 right here, the radio on the bench has a 66, which is fine. Let's talk about the layout of the radio. It's really pretty darn straightforward. There's a power supply section, which is all of this. Actually includes these resistors in my mind, but it's all of this stuff right here. This is all power supply. Here's the primary side of the power transformer. We have 3 secondaries, one here, and one here. This one is actually for tube heaters. You'll see a couple of arrows here. These small arrows correspond with the tube heaters on the tubes here. So these two just do tubes. What else can we say? It does have a pair of filter caps right here and right here. Again, if this is the first version of this, the schematic is the first version of the chassis. The last version doesn't have this filter cap here. This .05 is gone, as is the 5K, as I recall. Up here at the top row, we have radio signals from your local radio station coming in here. They get detected and turned into the IF frequency, which on this radio I think is 560 kilohertz. Goes through the first IF transformer. Sorry, that's the local oscillator right there. So this is the oscillator that oscillates at the incoming radio station's frequency plus 560 kilohertz. This is the first IF here. Feeds the first IF amplifier, the 78 tube that we've been talking about. The second IF transformer is here. And finally the detector, the thing that turns IF into audio frequency, is here. And then at last we have the output tube, the 42 tube, which is right here, which feeds the audio transformer primary, this 400 ohm side, and the secondary is tied to the speaker voice coil, which is right here. Oops. Right here. And part of this is 0.89. I can't tell which it is. Either this little loop or this little loop. I think it's this little loop here. Is a humbucker. Means it's wound backwards from the voice coil itself and prevents hum. So that's what we've got here. We've got a choke taking noise out of our power supply. We've got what else we have? We have a bunch of capacitors stuffed inside cans. This B right here indicates that it's one of a series of capacitors. Oh, well, it's that B right there happens to be this B right here. So that capacitor is inside this filter condenser bank that has 4 capacitors in it. What else is interesting about this? Not much. Here's our volume potentiometer right here. And here's our on-off switches right here. We have some dropping resistors. These guys right along here to give specific voltages to the tubes. We have another couple of dropping resistors here. These are the really high wattage ones. Wire wound most likely, 32 ohms and 235 ohms. Again, setting some voltages for the tubes. Now what I want to talk about is what to look at before you turn the radio on. And let's start with this innocuous looking little capacitor right here. Capacitor number 49 is a 0.015 microfarad capacitor. It's tied, you'll notice, from one side of the primary to ground. The purpose of the capacitor is to run noise that comes in on the AC line to ground, so you're not injecting a bunch of noise into the rest of the circuit. But imagine, keep in mind that when this radio was built, we didn't have polarized outlets. There was a hot side and there was a ground side to each outlet, and depending on which way you plug the cord in, you either had the hot side over here or you had the hot side over here. Now let me back up for a second. If you had the hot side over here and this capacitor shorted the ground, nothing would happen. It would just short this side of this transformer to ground, and you'd still have the hot side over here, and the radio would continue to work up until the very moment that you unplugged the radio, turned the cord over, and then got the hot side over here on this side, at which point you're running the hot side of your house directly into ground, and you're going to blow a fuse or throw a circuit breaker in these days, but the days this was built, you'd blow a fuse. So this capacitor right here needs to be checked to make sure it's not shorted. In fact, the easiest way to take care of it is to just clip it out of the circuit and replace it later. That way you don't have this potential for a short. The other thing to think about too when you plug in a radio that hasn't been turned on in a long time is this may work for 10 seconds, 10 minutes, 100 days, and then short. That capacitor may go at any moment because it's old and tired. So that's the first one I check, is the capacitor attached to the primary of the power transformer. The second two capacitors that I don't even, particularly on a radio this age, I don't even check, there's no reason, are these two guys right here. These two filter caps, unless they were replaced yesterday or something, both need to be replaced. The ones that are in the Philco on my bench haven't been replaced. The original ones are gone. But the replacements have got to be 30, 40 years old. And they're just going to be tired. We'll look at them later and see if either of them are bulging. But by default, I'm going to replace these two without even trying to turn on the radio. And why, you say? Well, what we've got here is a lot of voltage across our rectifier tube here. And when you short, the current that flows through the tube is controlled by these capacitors, by, whatever is hanging off out here. If one of these capacitors shorts to ground, or shorts across the secondaries of the transformer, a couple of bad things can happen. One is the tube will blow out. You'll just melt your rectifier. The second is you'll melt your the secondary of your power transformer. So I don't even mess with them. There's no point. It doesn't make me feel good to cause smoke when I plug in an old radio. I just know that these two need replaced. I replace them, then I move forward. The last one that I absolutely replace in every instance is this guy right here. This is the coupling capacitor between the detector and the output tube. The coupling capacitor is connected, you'll notice on the left side here, directly to the plate of the 75 tube. The plate of the 75 tube is at several hundred volts. It's going to be high voltage. If this capacitor right here, oh, I should back up. So this is very high voltage at the plate of the 75 tube. This is the control grid of the output tube, the 42 tube right here, and it's at a very low voltage. The higher voltage this control grid goes to, the more current passes through the output tube, and pretty soon, if it gets too high, you'll have enough current flowing through the output tube to burn out the tube, and in the meantime take your audio transformer as well. So your output transformer right here. So if this tube is overdriven, you'll destroy the tube, you'll probably destroy the primary and secondary, maybe secondary of your output transformer. So what happens is if this capacitor shorts, all the positive DC voltage that's on the plate of the 75 tube gets carried over immediately to the control grid of the 42 tube, and it goes into overdrive, super ultra drive, and burns itself out. So this is the fourth one in this radio that I will replace without even thinking about it. I won't try anything else. If I replace these 4 capacitors, and there's one more that's questionable and we'll talk about, or 2 more actually in this case we'll talk about, that need to be looked at for sure. But if I replace these 4 capacitors, then I've lowered the risk of turning on the radio way low. It's much safer, much more unlikely to damage the radio. So what I will do is replace these 4 capacitors before we even start. The other 2 that are kind of questionable are these guys right here. There's some pretty high voltage running in the, is there? Yeah, maybe. I'm not sure actually. I was looking at this one here, this 0.18 microfarad. I'm not sure I would replace that. It looks, if it's shorted, all it would do is ground the cathodes of these 2 tubes, which probably wouldn't be any great damage. So I wouldn't replace that one without looking. The other one that's kind of interesting to me is this guy right here, this 10 microfarad capacitor. And that might be an electrolytic. I'll have to look it up. Where's the parts list here? I'll have to look it up. This might be an electrolytic as well. It might be the one that's in the can. If this is an electrolytic, but even if it isn't for sure, I will take a look at it and replace it, because you'll notice this is the high voltage again coming out of a rectification or a power supply, and if it shorts, it'll short all of this stuff to ground. So this guy, I'll change the color on that, in fact, to red in this instance. I will definitely examine this, make sure it's present, and if it's an electrolytic, I will definitely replace it. So 4, perhaps 5 capacitors to be replaced before I would dare to apply power to this radio.